In this video, we'll be introducing the iTuner. Focus Microwaves has the largest portfolio of broadband fundamental tuners on the market today. These coaxial impedance tuners range from 100 MHz to 67 GHz. All tuners are Ethernet controlled and have an onboard processor, memory, and firmware with interpolation and tuning capability, making it a fully standalone instrument. The iTuner series is optimized for broad bandwidth and high RF power. Each tuner contains 1 to 3 wideband probes which cover different frequency ranges for maximum tuning range. The iTuner is used in many applications. It's often used in highly complex systems where engineers want an easy way to vary the load impedance within their own test executive. Probably the most popular application is for ruggedness testing. Ruggedness refers to the ability of the RF power amplifier to withstand various load mismatches under high output power conditions without experiencing device failure or measurable long-term degradation in the device performance. Under mismatched load conditions, a large amount of power can be fed back to the device where it's dissipated in the semiconductor. The ability to handle this large power dissipation internally without altering the performance is indicative of a reliable device. The automated calibration procedure is simple. We record a matrix of XY position and S parameters. Calibrating iTuner using FDCS makes it easy to calibrate multiple bands of frequencies in minutes. You simply connect iTuner to a calibrated network analyzer and the software does the rest. Engineers are only interested in knowing what impedance is presented at the DUT reference plane. By simply adding an S parameter file, you can shift the reference plane from the tuner to the DUT at multiple frequencies. A special group of commands were designed to make constant VSWR testing straightforward while taking full advantage of iTuner's tuning and de-embedding capabilities. Although the tuner itself is matched in its initialized state, adding adapters and cables between the tuner and the DUT results in a VSWR shift, as shown by point A in this figure. Moving the horizontal axis of the tuner while keeping the vertical axis at a fixed position would result in a non-constant VSWR at the DUT reference plane. This is represented by the dash circle in this figure. The VSWR family of commands of iTuner automatically readjusts the vertical probe position to keep the VSWR seen by the DUT constant during all phase sweeps. The iTuner is controlled via TCP/IP connection to a host computer. The TCP/IP interface is compatible with all major operating systems and programming languages like C++, C#, Python, LabVIEW, and Keysight-V. No additional hardware beyond the network card in the controlling computer and a network cable is required to operate the tuner. Commands are sent to the iTuner in ASCII format, and the iTuner replies with a result string to acknowledge reception. Thanks for watching, and please contact us for more details.